The use of lattice structures to provide lightweighting for designs is becoming more popular and prevalent, especially with the adoption of new 3D additive manufacturing processes. Earlier on this year in NX 1102, we first introduced the ability to generate a lattice structure, and in particular a unit graph lattice structure, which means you're able to fill a solid volume with a lattice structure to provide the lightweighting. Now in NX 12 we've added the ability to specify a conformal graph lattice, and that means we can create a lattice that exactly follows the form of more complex shapes. These conformal lattices are particularly useful when you're trying to solve certain problems, such as the uniform cooling of hot surfaces or the cushioning of plastic parts, or if you need to have uniform bone growth for a medical implant. So the inclusion of the conformal lattice type in NX 12 will give the design engineer more flexibility when designing components that need lightweighting. So let's take a look at an example of each type of lattice structure, both unit and conformal graph. Here we have a connecting rod, and we want to achieve some weight reduction. And to do this, we're going to use lattice structures, specifically around the main body and also just above the bearing area. The first lattice structure we'll create will be for the main body of the connecting rod. We select the unit cell we want. It is a unit graph type, and we select the void area in the middle of the conrod. We select apply, and our lattice structure is created, which is a convergent body. So that's one lattice structure complete. Let's take a look at the other one we want to create, around the bearing area of the connecting rod. This one's going to be different because it needs to follow the shape of the slot that you can see in the center there. So this time we're going to use the new conformal graph type in NX 12. The base geometry for a conformal lattice is a face and not a volume as it is for the unit graph. So here we have a surface that's midway between either sides of the slot, and we will use this to base our lattice design on. As per the unit graph type, we select the unit cell type we need, and then we select the base geometry, in this case the face. We also have the option to add an extra layer and an offset to achieve the desired result. And there you have it, a lattice structure that follows the shape of the slot within inside of the conrod. This is a conformal lattice. So just to recap, in NX 12 we now have the ability to generate two different types of lattice structure, either unit graph or conformal graph, and the decision of which one you use will be dependent on the application required.